In this video, we will talk about redo logs in MySQL. First, let us talk about the function of redo logs in MySQL. Redo log is used for instance recovery after a database crash. Redo logs are used by MySQL background threads to do instance recovery. For crash recovery, DBA doesn't have to do anything with the redo log files. When the instance is restarted, MySQL automatically applies data in the redo log files that were not committed to the data files. But please remember, redo logs are not used for point-in-time recovery like it is used in Oracle. Redo logs are used just for instance recovery. Point-in-time recovery in MySQL is done using binary logs. Another thing to note is that redo logs are created at server level, not at a database level. In other words, each database does not have its own redo logs. All databases have a common set of redo logs created at the server level. When a server is created, 2 redo logs are automatically created. The size and number of files can be changed in the mysql file. Redo log files are named by the server. It cannot be manually changed. Redo log files are named as follows by default. IB_log file 0, IB_log file 1. Additional redo log files created and size of each log file can be changed by changing the settings in mysql. The size and number for redo log files can be set using parameters inodb_log_file_size and inodb_log_files_group. inodb_log_file_size sets the size of the redo log file. inodb_log_files_group sets the number for redo log files. Maximum total size of redo log files can be 512 GB. This means inodb_log_file_size multiplied by inodb_log_files_group cannot exceed 512 GB. Recommended value for inodb_log_files_group is 2. inodb_log_file_size and inodb_log_files_group parameters are deprecated. New parameter is inodb_redo_log_capacity. If you use inodb_redo_log_capacity parameter, then MySQL tries to create 32 redo log files with each file size equaling inodb_redo_log_capacity divided by 32. For background log threads are responsible for writes of new data to disk. Log writer writes from the log buffer or write-ahead buffer to OS buffers. Please remember that log writer does not write to the disk. That is done by the log flusher thread. Log flusher writes from OS buffers to disk using fsyncs. Log write notifier notifies user threads about completed writes to disk, which happens when write_ls is advanced. Log flush notifier notifies user threads about completed fsyncs. 2 background log threads are responsible for checkpoints and subsequently reclaiming space in log files. Log closer tracks up to which ls and all dirty pages have been added to flush lists with respect to oldest modification. Log checkpointer determines the value of the variable log available _for checkpoint _lsn and writes checkpoints. Redo log files are a sequentially written, append-only type of file, unlike a data file, where data can be written to specific locations in a data file. Sequential writing makes sure data is written much faster and can capture data in case a crash occurs. Redo log files are populated and emptied in a circular fashion, i.e., first IB underscore log file 0 is populated, then IB underscore log file 0 gets full. IB underscore log file 1 is populated when IB underscore log file 1 is full, then data in IB underscore log file 0 is emptied and IB underscore log file 0 starts getting used again, and so on. Please note that if the redo log ever fills up, writes to the database stall until an emergency checkpoint frees space. You can disable redo logs by the command alter instance disable inodb redo underscore log. You should use this command only when doing a bulk load into the database, and redo logs should be enabled immediately afterwards. Thanks for watching this video. Hope you found it useful. Please click the subscribe button below. It will encourage me to create more videos like this.